process group with ISIS. I'm going to use this as a chance to demonstrate how one uses Visual Studio to do programming with the
software environment. So we're basically going to implement Hello World, but because ISIS is a distributed computing environment, our version of Hello World is going to be a distributed program. And I think what we're going to do here is start with the example that was used in the introduction module, but we're going to develop a slightly more interesting and more useful version of it. So ISIS, of course, as we saw in the introduction, is a system that lets you build normal-looking programs, but let them form associations with other programs, these process groups, transfer information that initializes the joining program so that it's in the same state that the other members were in, and then after that, updates that are applied to the data replicated by the group are applied to all the members in the same order in a consistent and fault-tolerant and secure way, and that gives us a guarantee of consistency across the group, and we can also make the group remember its information, make it persistent, and we can connect it to outside data sources of various kinds. So we're going to be doing that, and we're going to be able to do read-only access to individual copies, and we're going to illustrate all of those different features in one little program. This is just a reminder of what we reviewed in the introduction module, where we had a small group that stored a key value collection in what was called a dictionary, the values object. It stored strings and indexed them to double precision numbers, and it could fetch them back, and then I illustrated that with an ordered send, which is a multicast, and an ordered query. So we're going to build on these ideas, but we're going to form them into a slightly different program. And in particular, the multi-query that we did in the introduction module, which is illustrated on this slide, wasn't a very smart multi-query, and the reason I say that is because all the different members sent back the identical reply. It makes much more sense to get some parallelism, and so in fact we're going to work on trying to have the different members do different but useful work, and when we add the replies together, an action that's called aggregation, then we end up with a single answer that reflects the opinion of the entire group on the question that the query asked. This is the program we're going to be working with, except it's missing code for what's called state transfer, which we're going to see isn't really needed for the example I'm going to be doing in the demo, but might be needed in other settings. I will show you the state transfer code that would have been used for this, but we won't be working with it today. You don't have to look at this slide in great detail. You can actually download this program off of the same website where you're watching the video from. And in fact, we're going to develop it as we go, and then we're going to look at little pieces of it, piece by piece. But here it is as a single entity. Now, I'll comment that this program hangs when it finishes. So we're going to run this thing, and it's going to do a little work and just sit there, and we're going to have to kill off the copies. A smarter way to do this would be to arrange that one of the members, let's call it the leader, in ISIS we generally say that the first member to join a group is the leader. The leader could, for example, wait 30 seconds at the end and then terminate the group. That eliminates the group and causes a new upcall to be done to the view handler saying that there are no members left, and you could arrange that at that point the group members all exit. If they were to exit by calling ISIS shutdown, the effect of that is that instead of hanging, the main thread will actually gain control and be able to terminate the program. I'm going to suggest that as a little bit of a homework challenge. You take this piece of code and modify it exactly in that way to make sure that you understand how to make changes, recompile, and rerun this kind of a program if you wanted to. So, let's pause for a second here, and I'm going to switch over to Visual Studio. Okay, as you can see, I'm now running Visual Studio. I've launched it, and I'm going to tell it to create a new project, and I'm going to create a C# program that runs out of the console. Now, I should comment that Visual Studio understands how to build all sorts of services, web services applications with remote clients. It understands how to build things like RESTful services. There's a Windows communication framework which allows you to build very fast remoted interfaces. You can build GUI applications that talk to the user through a nice interface. So this is really just one of many options. It's an easy one for me to demo though, so we're going to pick console application. And when I do that, what happens is the Visual Studio creates a new application program intelligently called console application 9, and it doesn't have anything in it. If I wanted to, I could put a line of code. For example, I could write console.writeLine, hello world. No demo is complete without a hello world example. And then if I run it, here's one way to do that. I can click the Start Debugging button. A second way to do it is to type Control-Shift-B, which builds a copy, and then we could actually run it from a little folder. And I'm going to show you that behavior in a minute, but right now we're going to build it this way. And so if we ran this program, you'll see it pops up a window. Oops, it vanished. How do we know it was in that window? It went away so quickly we didn't get a chance to see the console say anything. So let's just put a sleep here. 10 seconds perhaps. Okay, oh, that doesn't look right. I tried to type thread and it changed it to something else. You know why? I haven't included the thread package. And when I type thread, it doesn't know what it means, so it tried to auto-complete it, like spelling checking. But if I ask it what the problem is, and by the way, the problem also shows up here at the bottom in the error list. Thread does not exist. And then I can right-click on that and tell it to resolve this, and it says, oh, you might have wanted to include the system.threading package. Now it goes away and turns to this other bluish color. And now if we rerun our program, it prints hello world. You see it up here at the top? Sleeps for 10 seconds. Count to 10, I suppose. And then it resumes, and what will happen when it resumes is that the main thread returns, which actually exits the program. So one way for a program to exit is the main thread it's executing can return. Keep that in mind, we're going to be needing it later. Now, in order to use ISIS in this application, I need to copy ISIS onto my machine and put it in the place where we're working here. So let's find that place, and we're going to make that kind of a copy of it. So what I'm going to do is I'm going to go to Ken Berman's documents file, okay? And this is where Visual Studio stores things in Visual Studio 2010, and it stores it under projects. And remember, it was console application 9, and the source files are in here, console application 9 / console application 9. And there's our program is, by the way, this thing called program.cs. And if I want to copy ISIS into this, what I'm going to do is I'll run my browser, and I will go to isis2.codeplex.com. Remember the 2. If you type isis.codeplex.com, you get a completely unrelated project that had no business using the ISIS name. It was mine 30 years ago, but somebody else snuck in and stole it. And so now there are 2 ISISes. Mine is called ISIS2. That's not actually why we call it ISIS2, but it's a good reason too. And if you look here, we've got source code, downloads. We're going to actually download 2.1.1407. Documentation. Now, documentation has a lot of information on using ISIS. For example, if you load the CHM and CHW files onto your machine and put them in the same place and point a web browser at them, you get one of those nice clickable interfaces that tells you all about the documentation for all the different APIs in ISIS. You just put those 2 files someplace convenient and you can click on it. There is a long user's manual that explains how to use ISIS with lots of examples. There's some information on using it from Python, C#, normally C++, CLI, how to move ISIS over into a Linux environment, very easy to do using something called Mono, which you can install. And then you can see all the videos that you've been watching are right here down below in podcast version and also in a clickable version called Panopto. And the demo we're doing right now is down here at the bottom. So this is where that stuff is. And then you've got a place where you can post discussion threads with questions or comments about ISIS. An issues thread where you can find out about bugs or you can report on bugs. You can see all the bugs shown here are green. That means they've been resolved in the beta 1407. Information about people. I'm the main people. Licensing. It's what's called the 3-clause BSD license, and so forth. So we're going to do a download, and we're going to download 2.1.1407. Here it is. And I would like to download it to this folder that we just came up with. So we're going to go up to here to my Documents folder. But we don't want the one called Library Documents. We want, there's a Documents folder off my desktop. That's the one we really want. Let's see if I can find it for you. We want C user can, here we go, let's go there. Users can, that's where we should find documents. My documents, there we go. Visual Studio. Here's my projects folder, console 9, and this is where we want to put it. So we're going to save it right here. And you see what I've actually done is to download the entire ISIS library as a single file. I know that's considered terrible style, and I agree it's terrible style, but it certainly makes it easy. Now, how do we connect this to the project? We're going to go back to Visual Studio, and if we go to View and tell it we want to look at the Solution Explorer, this window on the side, we can now tell it to go into this console application program and add to it an existing item. And gosh, there it is. Double click on it. And now, ISIS.c, the entire source code for ISIS is available to you. You could even edit it. And in fact, that's not a terrible thing to do. Although generally you won't need to edit it to work with it. What you'll be able to do is to pass parameter settings into it through what are called the environment variables. So now that I've done that, I can actually say that I want to work with ISIS by just putting the using line, just like that. And now, if I were to call ISIS_system.start, there it knows about ISIS, you see, and I can say start. This will cause my little programs to not just print hello world, but to also launch the ISIS app. Now, the only thing I should explain at this point is that if the main thread of an ISIS program terminates and exits, then ISIS shuts down on that copy. We want this one to linger. So what I'm going to do is instead of thread.sleep for 10 seconds, I'm going to add another call to ISIS system. And my call is just going to say wait forever. Okay? And what that does is it waits as long as ISIS is still running. Although if ISIS gets shut down, wait forever would return. And in this program, if wait forever returned, the main thread would return. And if main thread returns, the program terminates. So in fact, right now, this program runs, launches ISIS, and sits there until someone shuts ISIS down. And so let's run a copy of this program. And I'm afraid it's going to be very boring. In fact, maybe it might not make sense to say hello world at the front. Let's say hello world internally and say hello world, ISIS is running. And the reason we want to do that is that when we run it, we'd like to kind of know how long ISIS_system.start takes. So if I launch it, it's printing a line that wasn't in the code that we just typed about searching for the ISIS oracle. What you're going to find is that ISIS prints out some information as it runs, mostly when you launch it. You can mute ISIS and prevent it from doing that, but it gives you some sense of what's going on. And in fact, it doesn't just print this stuff out. It also puts it in a file. If I go down to console application 9, look at this in the bin debug area. Do you see this folder called logs? There's a file being created which contains what ISIS printed plus a little more information. So as you can see, the version of ISIS, some of the main runtime settings that were used, including what's called the port number. If several people develop an ISIS application on the same internet, same network, those applications will potentially collide. If they use the same process groups, the groups will try to connect to each other. I kind of recommend that you change the default port number to a slightly different value. Here's the default port numbers. It's 9753 and 9754. You can see them there. It might not be a bad idea to use 98753 or some other random number kind of in the same range. The value doesn't really matter very much. If you're 100 ports off from everyone else, you'll be working by yourself and you won't risk this issue of conflict, where it wouldn't matter terribly much unless you chose the same group names. But if you did, you'll be trying to develop something called My Group, and they will be, but the two versions of My Group won't be identical. They'll try to sync up, and they won't sync up, and programs will crash. All right, and then you can see after printing a little bit of setup stuff so that I can debug if you have a problem, it prints the exact same stuff that you saw just a second ago, except the console window printed hello world ISIS is running, and the log file didn't. That's because the console window is using I printed in the program to console.writeLine. If you print it to ISIS.writeLine, it puts it on the console and in the log file, which is nice for logging information when you're debugging. Debugging by printout may seem kind of backwards, but it's a good way to work with ISIS, and I'll show you why. Suppose we go back to Visual Studio and we pause our program. What you're going to see is that ISIS has a whole lot of threads running. Let's count them. One, but we don't even have to. They have thread IDs, 38, and it started, the main thread here was 9. So you can see we've got 29 threads running. That may seem crazy. It turns out in ISIS we use threads pretty heavily to watch for incoming messages and pull them off the wire in a microsecond. Those threads are idle unless a message shows up. So having a lot of threads isn't such a terrible thing. But when these threads are launched, they end up in this threads pool. So you can see that you could use Visual Studio to debug an ISIS program, but you're going to have to wade through lots and lots of my threads to find the code associated with your threads. That's a pain, and so printouts into the log file can actually be an extremely useful way to do debugging. Now, what if you don't want printouts in the log file? In that case, you set an environment variable called ISIS_mute, ISIS_capital mute to true, and none of this output will appear in the log file. It won't even create a log file. So you can control whether or not that log file is created. You can determine how verbose you want your program to be. Well, we don't want this one to be so verbose. Now I'm going to stop this program, and I'm going to close that little log file I showed you. And what we're going to do now, now we're in the library by accident. Here we are, back in our program. Let's have the program create a process group and send a multicast to it. All right, so it's running, and what we're going to have to do is say group G is a new ISIS group. Let's give it a name. Okay. And now we're going to attach a handler to it. The main handler that you've seen in the intro module was a handler for views, and a handler for multicast updates, and a handler for queries. We'll just attach the view one right now. So g.viewHandler plus equals. Now you have to give either a method name, which could be written further down in the code, or you can write the code inline using a delegate, which is what I prefer because, as we'll see, we can reuse variables that are locally in scope if we do it this way. And so if I do it, I have to tell ISIS, I have to actually tell C# what type of handler I'm building. I'm handling views, and there's a predefined thing called a view handler type for that. And then I can type delegate. The argument is going to be the view. And when this handler is called, which won't happen right away, by the way, it's only going to be called when the group membership changes. So it'll be a callback that occurs later, callback. Let's have it print the view. We'll use that logged version. It's ISISsystem.writeLine. There we go. View. And actually there is a toString method already defined for views. Prints them out kind of nicely. And the next thing we might do is let's change the console window. We'll put something in the title. Well, the new view is kind of long, so let's say view, and we'll print the view ID, which is a small number that increments. My rank equals, and I'll explain this in just a second, get my rank. There we go. Every view has a list of members, and every process is somewhere in that list, and every process that joined the group. And if we call get my rank, we find out what the rank of this process is in the group. So now we want to launch this thing, and the first thought you might have is let's run a few copies. But if we do it through the start debugging interface, we can't run more than one copy, because Visual Studio doesn't launch multiple copies as a limitation in Visual Studio. So what we're going to do is say Control-Shift-B to build the program. You see down at the very bottom left it said Build Succeeded. And then if I go to the folder we were in a second ago, and I guess you're wondering which was that folder again. So this is Visual Studio's Projects, Console Application 9, Console Application 9, Bin Debug. And I go up a level here because I was in the Logs folder. You see this executable? That was what Visual Studio built. And I can double click it to run it, and in fact I can run a few copies. So let's run 3 copies. Here's one. So the first one that runs starts the ISIS Oracle. This is an initial step that can take a few seconds, as you'll see. The second one that runs will find an existing ISIS Oracle, and so will the third, and they'll connect to it. We could have started them all 3 at once, and then they would have contended to start the ISIS Oracle, but one of them would have succeeded. We'll talk about the consequences of that in a minute. So let's take a look at what happens if I now run a second copy. You know, something's bothering me, and I hope it's bothering you too. Where's the view? Something's wrong with our program. Let's go back and have another look at the code. We'll kill it off. This is an easy way to kill multiple windows with the identical content. There they go. So let's go back to our little program and see what we did wrong. We set up a group. We attached a view handler. I hope you're thinking what I'm thinking. We forgot to join the group. Remember how in the intro module I explained that until you join a group, you're not actually a member of it? In ISIS, you have to set things up first, and then you can join. So we should have written g.join, and this will connect me to the group. So now let's rebuild it, Control-Shift-B. Go back down to our little folder, to the debug. There we are. Yes, it just got updated. Now I can run it again. Run it a few times. Let's run it once, and we'll wait again until the Oracle starts up first. There isn't a need to do that, and actually I could have told ISIS by passing a parameter to join that this first guy should start the Oracle instantly. But the trouble is I would have had to pass a true value on this guy and false for others. It's easier to do it the way I'm doing it now for the demo. So this time the view did get printed, and in fact we can also see that the console title changed. And so you can see that we have a group, its name is my group, it has something called a group address that's been defined, that has information about the IP address that would be used for this group. It has a view number that increments 0, 1, 2, 3. Currently has 1 member, and this is the address of the member. This is addresses in short form. There's a long form where you can see the host IP address, the process ID, which is what we're seeing here, and the port numbers, but I didn't tell it to use that format. It's a slight change to the code. To get it to do it, you just set a flag. And then you can see here that, well, okay, that's not showing you the full window. There we go. It shows some internal information that you won't need to access about processes that have been pre-announced as having failed but haven't yet been reported in the view as having failed. This is it comes up actually in the demo later. I'll explain it later, but let's not worry about it now. This is used by ISIS for delivering messages in order. This is for garbage collection. And then you see this field called joining. That's a list, actually an array, of members that just joined, and you can see that this process, 7716, is in that list. And here's a list of processes that are leaving the group, and this last thing tells whether this process is the 0 ranked member. It's called the leader if it is, and it is. And then you can see up here at the top left, in the console title, this is that other thing we did, console.title equals, view ID is 0, and it only printed its rank, which was 0. So let's run 2 more copies by now. So I'm going to go back to our little folder. There it is. And I'll just run it twice. And you see each time they join, and so here's, for example, the third one that joined, and you can see his view is 2 because there have now been 3 views reported, 0, 1, and 2. It only learned about the one where it joined, so it doesn't know in this particular window about view 0 and 1. We'll go back and look in a second. But you can see that it knows about view 2 where it got added, and you can see it added and 3 members. You see them? Here they are. Joining is 5556, and here are the 3 members, 7716, 7964, and 5656. Sorry about the tiny font, this is just what they use. And if I go back to the very first one that had joined, his rank is still 0. This is interesting to know.
When you join, you get ranked, and the oldest is always to the left with the lowest rank values, so those values don't change unless somebody crashes who was lower ranked than you. You see? So this guy is rank 0, and he stays rank 0 until a failure occurs. And then you can see the other members being added. And let's suppose that I do kill one of my processes. Let's kill the middle one. Here it is. Let's kill that one. Now, you would assume that killing it should have meant that the membership would drop from 3 members to 2. But why hasn't it dropped? ISIS needs time to detect a failure, and there are 2 different categories of how it senses that. If an application program shuts down voluntarily by calling isis.shutdown or by having its main thread return, in that case, actually, the notification really is instant, and I mean within milliseconds. However, when I kill a program, which is what I did, it can take as much as 90 seconds for ISIS to decide that that program has died. And the reason for this is because when we run on platforms like EC2 on the cloud, it turns out that you often see delays. And so to cover for that, we just wait a long time. And so now after about 90 seconds, you can see that in fact 7964 did exit. He's shown as having left the group, and we got a new membership view. This process is still rank 0, but if I go to the guy who used to be rank 2, now his rank has changed from 2 to 1. You see? He used to be rank 2 because he was the last one, 5656, and that was 0, 1, 2. So he was rank 2 when I first showed it to you, and now he's ranked 1 because of the new membership view. You see? All right, so we can kill this program by now. And if I wanted to, maybe I'll do a teeny bit more with it, and then we're going to go back. Suppose I wanted to add updates of some kind. Let's define a small integer constant. We'll say constant int update. Update, that's not right. Update equals 0. And you should use numbers that go from 0 up. And then we can define an update handler. So what would that look like? G.handlers, these are up calls for incoming messages. And messages have a category. We just decided to call it update. And we're going to say plus equal. We need a delegate again. Now this time ISIS doesn't know in advance what the type signature is going to turn out to be. We have to decide. So the way you handle that is you're going to use something called action, and it's a generic, and we're going to tell what the types of the arguments to this delegate will be. So for example, if we had an update with no arguments, it would look like that. If we have an update that receives a string and an int, let's use that case. It would look like this. And now we can type our delegate. And it should take a string s and an int I. And here's some code, which I haven't written yet. And I could, for example, put in something like ISIS system dot writeLine update. And let's put the string with value. And let's put the value. In C#, you can just build big strings up by adding. And so this is really string concatenation. This part's a little string, and then it attaches the string it got as an argument. And then after that, it prints the value of I. And now what can happen is after the join, I can do a couple of multicasts. So for example, I could say for n equals 0, n less than 10, n plus plus, so we have a couple of numbers, and let's do a g.ordered send, which is the most common and most useful ISIS primitive. I recommend that you always use g.ordered send unless you've got a good reason to use something different like safe send or send. And then remember to call g.flush if you're going to talk to something outside the process group, like a web service client somewhere. All right, so what are we going to send? We have to first of all tell it which operation we're doing. We'll say it's an update. And now remember, we're supposed to send in a string. So let's send in a string. The string is, and let's make the string, I don't know, let's say it's number n. Okay. That's good enough. That's a string. So it's going to look like the string is number 0, 1, 2, 3, right? And then let's, I don't know, we'll send in n times 55 as our little integer value. And if you think about it, what you'd expect is that when we launch this, as each member joins, it sends a burst of updates. The first guy who manages to join, he might do updates that no one else sees, but the third one that joins, everyone should see those updates. So let's launch our program. We better build it first. Control-Shift-P. Here it is. Launch a copy. As I mentioned, I can actually launch copies just like that, and they will sort things out. And if I do that, it's kind of useful in Windows to show them side by side. As you can see, what's going to happen here is it's going to pick one of them. It turns out the middle one is going to launch ISIS. It managed to do the join first. Then, as we saw, the process with on the right here with rank 1 joined second, and once it joined, it did 10 updates. And then the third process managed to join. Now, I should tell you, nothing stopped them from both joining at once. I just didn't manage to launch them close enough in time. They could have joined 2 at once, and ISIS would have done that if they really were concurrent. But in any case, you can see that the oldest one saw all the updates. The one who joined second saw most of them, but not the first group. And this is why we do state transfer, because if this group was remembering values, then this first set of updates here, these first 10, wouldn't have been known in some sense to the second guy. We would have to initialize him by sending whatever he needed. And similarly, when the third one joined, we would have had to send the full state over to him. And you'll notice they got the updates in the same order. They all got the updates. At least everyone in a given view gets all the updates in that view. This is quite a powerful set of guarantees. So I think that's enough with Visual Studio right now. Let's shut this down, go back to PowerPoint, and talk a little bit more about some of the functionality that the full test program has in it. I will run the full test program for you first, just so you see it run. So what I'm going to do is I'm going to exit Visual Studio here. That made itself small for some reason. Oh, it seems to be running twice. Well, I'll exit it again. All right, and I'm going to run it again, but this time the version I'm going to run, instead of Console Application 9, I'm going to run one called Console Application 8 that I built yesterday. Do you remember those old cooking shows where Rachel Ray or somebody is cooking lasagna and she puts it in one oven and then takes it out instantly from the second oven? Same idea. I pre-cooked Console Application 8. It's the same code, but elaborated to something quite a bit fancier. And here you can see the program. Now it's got an update and a lookup. It's also got some semaphores that are used as barriers. Now you can see the view handler, and then you can see its update routine here and a lookup handler. After the join, it does. This is the program we're really interested in talking about. And what I'm going to do is I'm going to compile this version. I'm going to go to the place I've got it located in, which is again in my documents, Visual Studio, there it is, projects, Console Application 8. Remember how it's in 8 bin, debug, there it is. And now I'll run 3 copies of this version, okay? So if I do that, I'm doing it simply to illustrate, so it's essentially the same program. I'll run 1 copy for you to see it. But now it's going to be putting more interesting content into an actual variable that captures the state of the group. It's not going to actually do state transfer. This version is going to arrange that it doesn't update it until it has 3 members. So you can see here's the second member joining. And now we're going to put the third member in. And this time suddenly we'll get a lot of output out. And what's happened in this, as it turns out, the first member is this guy in the middle. And the second that joined appears to be off on the right, no, on the left. And the third who joined is on the right. And then when they all had joined, a bunch of updates got done. You can see them here. And then some queries got done, and you can see that the queries were triggered a bunch of looking at messages, but the actual query results are printed over here in the middle, and it tells you what it got. You see this business like 201, 012, 210. Now, in what follows, I'm going to explain what that was and why those were there. And you're going to actually play with this program and do some stuff to make it a bit more interesting and fancier. Okay? So let's kill the program off. We're going to shut down Visual Studio, and we're going to go back to PowerPoint. We're not going to need this. We're not going to need that. And here we are with Panopto, which is our system. And if we tell Panopto to go back to PowerPoint and open a different presentation, okay, here we go. And we're going to try to understand the ISIS program we just wrote. So here's that program. It's too small to see, but let's talk a little bit about its main features. First of all, it defines a new kind of object called a tuple. Secondly, it starts ISIS, creates a group, and then attaches a view handler, an update handler, and a lookup handler. And here are the little constants I talked about. 0, 1, each type of action against a group is associated with one of these numbers. The queries are being done by doing an ISIS ordered query, which is way over here. Do you see that down at the bottom? Whereas the updates were being done over here from an ordered send. Ordered send, ordered queries, the idea is that they're in totally ordered relationship to one another. So let's go in and look at the program. So what the program does here is it forms a process group. Once there are 3 members, that's a change. Once 3 members are in it, each of the 3 sends updates, and they send them concurrently. The updates get stored into a list of what are called tuple objects, and we call it the database in this app. And then they all wait. But the 3rd member, instead of, I think it's the middle one as a matter of fact, sends some queries and prints what it got back. And when the queries come through, it was printing that it was doing lookups. Got all that stuff mixed together. But if you go back and look closely at the output, you'll be able to sort it out. And we're going to subdivide the work of searching a database. So again, I want to just remind you that you can suppress all the console and file output if you want to by setting isis.isismute to be true, or passing the environment variable isismute by using bash in Linux and saying bash export isis_mute equals true, or you can just say set isis_mute equals true if you're working in Windows like I am. But I actually find it convenient to have these log files around. I just delete them every month or so when they pile up. I find it useful because when something crashes, I can look in the log file, and I print all sorts of stuff into the log files when I'm debugging, and then I strip all that stuff out at the very end. I don't even remove it. I just turn isismute to be true, and that way if I have to come back and fix a bug later, I can reactivate all of its output. It works great. So the first program starts up, and that was where isissystem.start was run. And I wanted to start by explaining that a type of a consensus on who should be the leader and run the Oracle occurs now. The Oracle is a service running internal to ISIS. You don't see it, but it's in there. And it manages membership information for groups. And what happens is like in this picture here. So we had A, B, and C. I don't know which of the first and second and third will turn out to be A and B and C. But what happens if, suppose we've launched all 3 at once. The first thing they do is they holler out, "Is ISIS running out there anywhere, please?" So A and B and C all did that. And they collide, basically. They hear about each other. And what ISIS does is automatically to pick a winner, happens to use the one with the lowest process ID number, and it also breaks ties using the IP address number. And that'll be A. And A decides, I'm going to start ISIS, and B and C are told, don't try to start ISIS. And if you looked closely at the log files, you would actually see that A doesn't find the Oracle, but B and C say that they found the Oracle and they're waiting to join, and they start printing little dots. That's what's going on there. So A starts ISIS up, and B and C are now in a mode of joining a running ISIS system. The green is that ISIS is already running. Red is that they haven't started up really yet. B gets added, C gets added, perhaps both at once. And at that point, they're all green. But I do want to point out that there was a brief period where A was a bit ahead of B and C, and we're going to see that that's significant in the way that our app runs. I'm going to comment quickly. There is a much faster way to start ISIS, so we don't wait 45 seconds while A is hunting around. Maybe it's a bit less, 25 seconds. However, it's a little fancier. You can see the description of it in the manual, but if you use that feature, A will start instantly. However, you have to run A, B, and C in different ways. You have to run A with a start, isysystem.start with a true as an argument, and B and C with it as false as an argument. Basically, are you the leader or not? If you skip that, which is what I did, then it figures it out for itself. So that's something you can do. There's also a way to start large numbers of programs if you wanted to start 1,000 simultaneously using something called the master-worker relationship, but let's not worry about that today. So is this all fault tolerant? And the answer here is that we can't really guarantee consensus in a fault tolerant way for a distributed system. However, there's a theory of that. We can come real close. What ISIS does has an extremely high probability of correctly launching. It has a small probability of starting with 2 leaders, but they kill each other off within about 10 seconds if that happens by accident. So you could conceivably see 2 leaders if you started them exactly at the same time at a moment when the message loss rate was very high in a network. But were that to happen, 10 seconds later one hears from the other and one of them shoots itself down, the other keeps running. That's probably not the behavior you would want. You'll probably never see that though. Okay, so what happens next? We have this initialization where A attaches handlers, and as you've seen, what you have to do is attach a type signature, either a predefined one like the view handler, which is a predefined type signature built into ISIS, or you may have to define a type signature of your own. This particular delegate has 2 integers as its argument, and so it's of type action int. And then you can write the code, and the idea is that this code will be called later. ISIS is actually very multi-threaded. You remember I showed you that? Some of those threads are in charge of doing upcalls into your application group. And in fact, there is one thread for view events and also used for multicast events. So view events and multicasts are on the same thread upcalls. And there's a second thread for point-to-point messages, which ISIS does support. You can do a P2P send or a P2P query. And those upcalls occur in a separate concurrent thread. So you better be careful with locking if you use that feature. You don't have to be using locking if you limit yourself to the view thread, which is what I did, the view multicast thread, which also delivers queries, I should say. So views, multicast queries are all on one thread. They upcall to you process them, and the next such event can't be delivered until your code returns, which, by the way, means you must not block inside a view handler, a multicast handler, or a query handler. If your code stopped at that point, you would be at risk of deadlock because ISIS can't deliver new views, updates, or multicasts in that mode, or queries in that mode. It's waiting for you to finish processing the one you already got. In effect, your program has wedged, and perhaps wedged long enough to crash. So it's very unwise to do long, slow things in these handlers. Fork off a thread if you have a long, slow thing to do. Okay, there's always a way to do that in ISIS, very easy. Read the manual section on it, it shows you some examples. So these delegates, they're really methods that I haven't bothered to give a name to. C# gives the name to the method for me and pulls it out of the inner body and puts it off on the side. The reason I like using delegates is because they can use variables that are in scope in the spot where the code appears, and as we're going to see, that's quite useful in our code. So these method handlers can actually touch variables like, for example, G is a variable declared in the scope of the main program. And those variables give us a kind of shared context, which I find very convenient. So then it calls join. Now, so these variables that are accessed during in the delegate, the way it works is that the the thread that delivers views, multicasts, and queries, that thread calls you with arguments, and the arguments might be the view pointer, or they could be content extracted from the multicast or the query. Okay, but in addition to that, you have access to any variables that were visible in the scope where you see where the delegate was declared. So here's an example. In this piece of code, which has this thing called the database, here it is. It's a list of something called tuples. I declared it up at the top of my program and then used it inside this handler down here. You see database.add? That's a reference to something declared outside. In fact, it could even have been a local variable declared in the main method. That would have worked too. So you get pointers. you can read about how C# handles these external references, but basically it handles them by passing them as if they were extra arguments. And so if it was a pointer to an object, you're pointing to the real object. And if it was an object that was a base type, like an int or something, you're getting it by value. This particular handler, the update handler, receives an int and an int. It creates a new thing called a tuple, which just holds two ints. And we're going to see what the two ints are in a moment. It prints out what it got. It turns out that one of them is considered to be the rank of the sender of the update. Remember, these updates are being sent by the 3 members of our group. One of them has rank 0, 1, 2. So the rank will be 0, 1, or 2. And each one of them sends in something like 5 updates, and n is which update? 0, 1, 2, 3, 4. Okay? So we're actually going to see that this application got exactly 15 updates. Each one of them it stores as a tuple, although it flipped the order, it put it as n comma rank. So a tuple containing the value of n and the associated rank. And in this particular code, there's a semaphore, and we're going to see how it's used in a minute, called dbFull. When the database has exactly 15 objects in it, 15 tuples in it, dbFull.release is called, and that allows someone who's calling dbFull.wait1 to continue and make progress. And that code would be down below. Similarly, there's another semaphore, go. And these semaphores, the way it works, in C# you declare them to have an initial value, 0, and a maximum value. I'm using 1, which is, by the way, not the world's best choice. I should probably have used int.maxValue, but then it didn't fit on one line. This is a value where if the semaphore, and the idea is that release adds 1 to the semaphore. Wait1 tries to subtract 1, but it waits if the value is 0. So if I call wait1 when the value is 0, I pause. And if I call release 1, it increments it. And if someone was paused, they wake up and resume execution. Okay? And so this piece of code waits until my little database has 15 elements in it. I'm going to pause for a half second. I have to go to a meeting, and I'll be back in a second. Okay, I'm back. So let's move on to our next, oh, hang on a second here. It's not in presentation mode. There we go. To the next point. So the database, as you remember, has 3 members in the group who are going to turn out to send 5 tuples each one consisting of the rank of the sender, a number 0, 1, or 2, and then the value will be 1, 2, 3, 0, 1, 2, 3, or 4. That'll be sort of the tuple number, and that's the data. And so these pairs are being put into the database. And remember now that each separate instance of the group has their own private version of this database variable, and they're applying the same updates in the same order to the different replicas. Okay? So now, as each one reaches 15, it'll be at the same point, almost the same time concurrently in time, what's going to happen is they're going to toggle the semaphore, dbFull.release. That's going to wake up dbFull down below. Now, where I was heading with this issue of initialization is the following problem. If I initialize to 0, 1, and I only call release 1 time, then what's going to happen is the semaphore is going to go from value 0 up to 1, and the dbFull.wait1 will decrement it to 0. We'll be back at 0. But you'll notice that this this update handler could conceivably trigger a second time if we start modifying the program. All right? Similarly, the view, which had 0, 1, 2 members, right? And when we got to 3 members, we toggled the other semaphore go. The view could go from 3 to 4 to 3, or it could go from 3 to 2 to 3. And if those kinds of things happen, we will attempt to do a second release 1. So if these semaphores had multiple releases done on them, they would eventually hit that threshold value of 1, and if you did a subsequent release, an exception would be thrown. Now, why am I telling you about this? Well, who would throw that exception, and how would it look to you if you were using Visual Studio? it'll turn out that the exception is thrown where the release is called. That'll either be this piece of code in update, if it was this one, or it would be in the view handler. And those calls are done from an ISIS thread, the multicast and view and query delivery thread, into an anonymous method created using a delegate. And that method will have a name, but it'll be a strange looking name. So an exception would be thrown from what would look to you like an ISIS thread calling a mysterious looking function, although the function name will mention main. It'll be something like main _ 2. So you'll look at this and you'll say something's buggy about ISIS. It has a semaphore and it throws a semaphore count exception because it calls release too many times, and you'll file a bug report. But in fact, if that kind of change triggered this sort of a bug, it would be a bug in your changed code, right? It'd be your code that was calling release more times than this limit on the size of the semaphore value allows. So the point I was trying to make is that you have to be a little bit cautious with ISIS to realize that things which are bugs in code you wrote, even lines of code that are right there throwing an exception, can look a little bit like code in ISIS at the time the exception is thrown, because of this issue of me doing upcalls to your code and your code perhaps being a delegate and therefore having an anonymous method name, which can make it look like it isn't your code. Knowing this, I've told you, you know this, you'll recognize that, oh, that's a line of code in my software. You'll stare at it, me now being you. This is a line of code in your software. You'll stare at the line of code and you'll say, oh my goodness, I'm calling release multiple times after the semaphore finished its purpose, and you'll fix it. You could, in this case, set the semaphore to have an infinite maximum value, for example. You could arrange to not do releases after that first time. That would work too. All right? So be wary that you can't ignore the threadedness of ISIS. You can't ignore the fact that these delegate upcalls are called by threads that aren't your normal thread. You can't ignore concurrency. These systems are intrinsically concurrent. Here's a way to visualize what I'm saying. You have this main thread that was running, and the main thread initialized the group and registered the handlers. Later, the main thread paused on that semaphore, the go wait one in this case, and then a new view occurred, and the new view was reported from this ISIS view and multicast event thread, which is running this, one of them for each group. There's also another thread that I didn't show for point-to-point messages. And that release is what wakes up the semaphore, the waiting semaphore. Okay? So here I have two threads, and you need to be visualizing that in order to understand what happens if a bug were to occur. The bug in this case would be an exception thrown here if this code ran again and again and again for some reason as a result of changes and extensions you might make to this template program. You see? And then the main thread goes to ISIS_system.waitForever, and we talked about how that would work. Now, wait forever is really one of several ways that you can keep the main thread busy and happy when it has nothing more to do. And what I mean by that is, think about the end of main. If it exits, as we've talked about, that will cause ISIS itself to shut down. That may not be what you want to have happen. You may want to have ISIS sit there waiting for events from outside and maybe GUI actions, and it may well be that you want ISIS to keep running. So if the thread that launched ISIS has nothing more to do, you just call ISIS_system.waitForever, and that will pause it at that point as long as ISIS is still running. Another possibility is to give it something to do. So if you're writing GUI code, you could call the GUI event handler. If you're writing a RESTful web service or a Windows Communication Foundation web service or some other kind of a system that has interaction, you can sit at that interactive point, and that'll usually have an event loop as well associated with it. Okay? I do want you to be cautious about multi-threading. Now, in our code, the database handler updates, they're being done in two different threads. Go back to this picture for half a second. Database is updated not from this delegate, it's from the updates delegate, and it was being accessed from the main thread. Why don't I need locks? Well, I might need locks. So if, hang on a half second here. Yeah, sorry about that. There's someone at my door. Okay, you might need locks. So in this particular code, as we've just seen, the main thread isn't running at the moments when these other upcall threads are running because the main thread is blocked on those semaphores. If that wasn't true, then you would really need to be cautious to use locking to do safe synchronization for access. So for example, you might have to write a piece of code that says lock the database, and then you could look at its count, or you could enumerate over it. Keep in mind that whether you like it or not, when you work with a system like ISIS at the programmatic level, you are doing multi-threaded code. I created those threads unless you create some of your own. Okay, and you need to have a mental picture of what kinds of concurrency patterns can arise, or you won't write your code correctly. Okay, so let's get back to our program. The process isn't even a member until join is called. So we set up the group, and then we call g.join. And what's going to happen at this point is that if the group doesn't exist yet, ISIS will create a new instance of it and will load its state from a previous checkpoint if you made the group persistent. If you didn't make the group persistent, it skips that loading state and the group starts in whatever state member A is in. Then when members B and C come along, they join the group, and if you've defined a checkpoint routine, a state transfer is done to initialize them. Okay, so now let's take a quick look at the picture from before. If you remember, there is a little bit of time during which A is active before B and C. And during that period, what really happens is A becomes the leader of the ISIS oracle. The oracle might also run in B and C. In ISIS, you can tell me how many copies of the oracle to run for fault tolerance. 2 or 3. 3 is common, actually, and it's the default. You could set it to 1 if you wanted to. Suppose it's 2 or 3, then B and C are also in the oracle, but even so, A is the leader. The leader turns out to be the first to change a view, and as a result, there can be a couple of milliseconds of delay between when A finds out about the new view and when B and C do, and that's enough time to send some multicasts. So you would actually expect in this program to see a burst of multicasts sent by A, but received by B and C before B and C managed to join. And you know, even a 25 millisecond difference is enough time to send a whole bunch of multicasts. Then you're going to see B and C join basically concurrently, and you'll probably get a mix of multicasts from B and C. So what you would expect to see is that because ordered send preserves FIFO-ness, is you would expect that when you look closely at the execution, you're going to get a series of updates from the rank 0 member, probably all finished unless you do a whole lot of multicasts. Then you'll see the new view events as B and C join in off on the sides, okay? And then they're going to generate their updates, and those updates are going to be received at process A, and the others actually, after the A updates were done, the rank 0 updates are done. I hope that was clear. So it's not that they were delivered in a different view. They were all delivered in the same view. It's that A heard about the view in real time a little bit earlier, and so it got a little bit of an advanced start on sending those updates. And since it sent them first, there's a good chance they'll get delivered first. It's just a real-time phenomenon. Now, what about the state transfer? Our program didn't really need a state transfer, and so we didn't bother to put one in. And the reason is that the way we coded it, all the members are in the group. There is a view with 3 members before any member starts sending updates. If you go back and look at the code, you'd see that. What it did was it stopped on that go.wait one until there were 3 members. And so there was always a view up call that reported 3 members before any process starts to do multicasting. The thing I was just talking about just has to do with whether there's a 25 or 50 millisecond gap in time between when A gets to that start point and when B and C do. But they all are in the same view. All right. Now, because of that, the state was empty, and that's a reasonable initial state for B and C. If we had modified the code, though, so that there might have been some data in the group before B and C joined, then we would need a state transfer. And what would that be? It would be the contents of the list database. So let's have a quick look at what the state transfer code would look like. We're going to need to have a make checkpoint routine and a load checkpoint routine. And we're also going to have to tell ISIS what the tuple data type looks like, because that's not a built-in data type, whereas lists and things like that, arrays, are. So we get code that looks like this, where g.make checkpoint needs to have a handler attached to it. It's an ISIS checkpoint maker type object, and it gets a view as its argument. There's a situation where there's some information in the v.offset field that might be useful. Plus, you may be interested in knowing who is joining. You can get that from the view. This particular code doesn't care about those values, so it ignores its view argument. And then you can see what it does is it sends a checkpoint containing the list of tuples, the variable called database. Then it says that's the end of the checkpoint. Then there's a corresponding load checkpoint routine, which has the exact same type signature as the send. Now, if you think about it, the send is sending a list of tuples, so that's the type signature. And that is received into this variable called incoming, which just replaces the previous database, or you could iterate over it and add them one by one if you prefer. I didn't do that. Okay, and then the join is after these things are registered. You always should register the event handlers for a group before doing the join, even though these routines are going to be called later at runtime. So here's a tuple. It's just it's a class that has the rank of the guy who sent the update and the counter n. Okay, and it stores the rank and the value. And what we're going to need to do is to declare to ISIS that this exists. And the way you would typically do that is you first put this line that says it is auto-marshaled. That tells ISIS that to send a tuple from one machine to another, it should scrape out the values of the public fields of the object. And the public fields are rank and value here. So those capture the data. If there were private fields or protected fields or internal fields, those would not be transmitted. Then there are constructors, and one other thing you're required to do if you use auto-marshalling is to have a constructor with no arguments, because when ISIS receives a message with a tuple, what it's going to do is call the null constructor. Then it will fill in the public variables with the values it got from the message, whatever rank and value was sent. And then one other thing you have to do is to call message.registerType. You'll give the type of your object, tuple in this case, and then a code which should be 0 through 127, which identifies these types of things inside ISIS messages that are being sent. And all the members of the group have to use that same code. When ISIS sees an entity of type 0, it's going to say to itself, oh, that is a tuple. You see? Here's a picture of what happens. Now, this is kind of interesting. So P, I should have called it A, really, because we were saying A and B before. But okay, so P and Q in this case. So P was running, and it pre-created the group. And let's imagine some events were occurring and that the database had some data in it. So now when Q joins, we want to transfer that data. Q executes at Q.join, and it turns out that hidden deep inside of ISIS is a thing called a future view, a preview, and here it is. Okay? Now, you don't normally see these previews reported to your application. There is a way to ask to see them, but you would not normally attach a handler to that event handling stub. I do that, though, internal to ISIS. And what that does is it gives me a chance to see who's joining and to call the state transfer routine. And so this is the point when g.make checkpoint is called, you see? And that checkpoint is a list of records of tuples in this case. And that list of records is put into a message by the ISIS message handler. And then on the receive side, it's loaded. And when that's been transferred, then we report the real view. And that's the point where you get the view up call event after the checkpoint has been made, but you're also after any multicasts have been delivered. That was done before the preview. So what happens here is that if there were multicasts to deliver in the old view, all of them have been delivered by the time this preview is signaled. So what happens is we flush out all the multicasts from the system,
Now the group is idle, so there's a pause. There really is a pause in data processing. Now we make that checkpoint, we load that checkpoint, and now we free the group to start multicasts again in the new view. You see? And that pause is pretty short unless your state is big, and if it is big, we use something called out-of-band data transfer to send it, which I discuss in one of the other modules. So now that we've added state transfer, could we make our group persistent and secure? What would we have to do? You could pause the video at this point if you want to think about it for a second. Okay, I guess you're back, or you didn't pause it. All we would add is 2 lines of code, and here they are. To make the group persistent, before we do the join, we simply say g.persistent, and we give a global file system file name where the state of the group can be stored during periods when none of the members are running. It has to be global because since ISIS often is used in the soft state tier of a cloud or a cluster, local files might not be preserved across shutdown restart sequences. But the global file system is always accessible. So you have a file name in the global file system, and what ISIS is going to do is store checkpoints using those same checkpoint making routines into that file name. And later, at the time of the join, if it creates the group, it just loads the most current checkpoint. And you can update those checkpoints. If you like to, there's a method to trigger the creation of a new checkpoint. And set secure says that the group should switch into an encrypted mode where any messages on the wire are enciphered with an AES 256-bit key. You can supply the key, but in this example I didn't. And if I don't supply the key, the group code generates a random number as the key and stores it in a checkpoint file using the user ID of the program that's running. And that way it sets up the permissions so only that user, that person, has permission to actually read the AES 256 key out, and therefore only that user can run programs that join this group in the future. So what does the program do? Initially it's running, it was A that wins, and A registers as view handler, and now as other members join, it watches the views change, and when the view finally reaches 3, then we're ready to go. And what you'll see in the little black window, the console window, is you'll see it printing out first that ISIS was searching for the oracle, and then you'll start to see a series of these view announcements until you see the one that reports that there are 3 members. And again, you can suppress all this information and you can tell ISIS not to log the data if you prefer to do that. But it's good for debugging. And what's in that view object that you just saw, most of the fields were being printed, but the ones you really tend to care about is the array of members, which is in v.members, or you can call v.getMembers getter routine. And it's an array of the number of members in the group in that view, and you can use the length of that list as a way to find out how big the group currently is. It would be v.members.length. Who just joined, v.joined. Who just left, v.leaving. And the ID number, which is going to be sequential from 0, and it's going to increment for each new view. The group address, which will be an address object, and the rank of each member can be computed by calling v.getMyRank or v.getRankOf. You see? And what's in an address? Well, the group foo has a group address object, and then there are also address objects for each process, which in short form only show the process ID, but if you were to use the long form, they show the IPv4 address, the PID, and then port number information, which in this case is 23451212. What happens is that ISIS always uses the default port numbers, which are something called ISIS_port number sub P for point-to-point communication, and then has a second one, ISIS_port number sub A, which it computes by adding 1 to port number sub P. But if you launch ISIS on a machine where somebody else has already gained exclusive control over those 2 IP addresses, like if you ran a couple of copies of ISIS and somebody started first, in that case, it lets Linux or Windows assign random port numbers, which is what must have happened here. Okay, and the view ID will be 0 if the group was just created. So when B and C join the group and the membership grows, you get more calls to this view handler. Eventually, it reaches length 3. Now the other thing the view handler is doing is each time an upcall occurs, this global variable called myRank is getting set to the size of the view.
I'm sorry, to the rank of this member in the view. So for A, that value is going to be 0, 0, 0, 0, because he was always the first member who joined. B and C join next, and one of them gets 1 and one of them gets 2. So even though they're running the same code, they're running the same code with one very important difference, which is that each one has a different value in this global variable myRank. And when we look at the code after go.wait1, we're going to see that the code uses the value of myRank to do different things if you're based on the different members. Okay, so go.wait1 is waiting, and then the release occurs only when all 3 members have joined. This, by the way, is the point I made earlier, this last comment, that if you let the semaphores get called, release 1 on the semaphores get called more times, and that might not happen here, but it could happen if you start changing this program, do be aware that you also are specifying a maximum value. And when you hit that value, an exception gets triggered, and it'll look like the exception was triggered in the ISIS code, but it'll really be your code that's executing at that point. It just looks funny until you get used to it because of the fact that there are multiple threads, and the threads have funny names, and they're calling, as it turns out, a method with an anonymous name. Okay? So what does this program actually do? The code that I've given you that you can download sends 5 ordered updates, and you can see each one of them, the sender sends his own rank, so that'll be 0, 1, or 2, and then they send the value of n, which is going to be 0 through 4. So A sends 0, 0 through 0, 4, B sends 1, 0 through 1, 4, C sends 2, 0 through 2, 4. So that's what's going to be in the database. And what we know is that the order could be scrambled because they're all using ordered send, which guarantees consistent ordered delivery. What won't be scrambled is that ordered send preserves FIFO order, and so you will see the A tuples in the order that they're in the column here. You'll see 0, 0 in the database before 0, 2. But it could be intermingled. It could say 0, 0, 1, 0, 2, 0, 0, 1, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 0, 2, 0, right? As I commented earlier, probably A gets a slight advantage in time, and there's a good chance that all the A tuples will show up first just because it runs this code first. But then B and C will catch up, and they'll probably be intermingled. So ordered send, just to remind you, is the most commonly used ISIS primitive. It guarantees that all the members get the message, they all get it in the same view, they all get it in the same order, that even failures won't disrupt this, and network partitioning won't disrupt it, but there is an optimism built into ordered send that makes it blazingly fast, but it does tell you that you should call g.flush, another primitive, before talking to the outside world, meaning a database that might be persistent, global file systems that may be persistent, or users who could be issuing web services RPC calls. Right? If you're not sure, you can safely call it if you like to. G.flush makes sure that any prior ordered sends have been fully delivered, and that means that the group can't possibly forget those updates. Otherwise, optimism allows one case where it could actually forget them, but it's a very unlikely case that you could ever provoke it because it involves multiple concurrent failures that would be nearly simultaneous of the sender of multicast and one of the receivers. So then these multicasts are getting received, and all they're doing is putting the data into the database and counting how many tuples are in it. And when the database has 15 items, what happens next is we're after this line dbfull.wait1. And so now we drop down into the next block of code, and this block of code behaves differently depending on the rank of the process executing it. You can see that the rank 1 member executes 3 queries, whereas the rank 0 and rank 2 members skip this line of code, and those end up at ISISsystem.waitForever just sitting. So these ordered queries, what happens is we set up a list for the results. We issue an ordered query that calls the lookup routine, and what it says is look up the tuples inserted by the guy with rank n. N is 0, 1, 2. So you're expecting to see the A tuples for 0, the B tuples for 1, and the C tuples for 2. And the real values we're getting back are the values, 0, 1, 2, 3, 4. Okay? And we'll see that in a minute. But those values come back as a list of ints. So we're going to get a list of ints because each of the three members will send a query reply, and each of those replies will end up in that list. Okay? And so what happens then is we iterate through these results. There should be 3 items in it. And then for each of those lists, we print out the value and then space after it. And so you're expecting to see 0, 1, 2, 3, 4. Because you're expecting that each ranked member, all the values he inserted are there, and he inserted them in an order and the FIFO-ness was preserved. So you're expecting to see that reflected even in these results. But what could surprise you is that the results themselves could come back in a scrambled up order based on who managed to reply fastest. So even though the data is in the database in the order 0, 0, 0, 1, 0, 2, right? It's in that order. You could still find that the results in the result lists have sublists which are individually ordered but not globally ordered, if you want to think of it that way. Do you understand what I'm thinking? That, so A replies first, but maybe A didn't have the very earliest of the items. All right, so the list of lists then is a list containing lists of ints, and that's because the replies in the lookup method are lists of ints in this code. That's a generic, and every member sends them. Here's the lookup routine, and you can see where that's happening, but this is a complicated piece of code, so let's lighten some of the lines and focus on them a few at a time. Basically, what you can see is it starts by printing query for arg equals, and it prints the argument it got. It creates the list of ints that's going to become the reply. See down at the bottom, there it is. And then it cycles through the items, and what is all this logic doing? Okay, well, what's happening here is, remember how we were talking at the very beginning about the idea we wanted to subdivide the work in our group? So that's what this application is doing. It indexes through the data, counting off, is this row 0, 1, 2, 0, 1, 2, 0, 1, 2. And each time a row, modulo 3, has a value equal to my rank, then this member looks at that row. Okay? So each of the rows is looked at by a different member of our 3-member group. Okay? And so here's an example where the database might have, for example, in it 1, 0 perhaps as the first tuple. In fact, as I said, I was betting that it would be 0, 0, but it might not be. 0, 0 as the second, 2, 1, 1, 1 as the third tuple. And what's going to happen is A is going to look at this one and this one. B is going to look at this second line and this fourth line. C is going to look at this third line and fifth line. And then they're going to look to see, let's go back to the code. They're going to look to see if the tuple rank field is equal to the given argument value. So they're going to look at this rank field and ask, is it equal to what I was asked to look for? Maybe I'm asked to look for 0. Here's one with a 0, and there's one with a 0. So A won't even look at a 0. B looks once at a 0, 0, 0. C looks once at 0, 1, you see? And then what it does is it sends back those lists. So what can we say about the order we're going to see in the tuples in the database? Hopefully you can see they're FIFO by sender, but on the other hand, different members of the group look at different rows. So although they're in order for what the rows say, when we combine them back and print out all the replies, we might not see 0, 1, 2, 3, 4 because the replies themselves may arrive in different order. And in fact, that's exactly what we're going to see in a moment. So here's the total piece of code again. And let's just walk through it line by line. The guy who invoked the lookup sent in the argument and sent in, that was the member with rank 1, and he did 3 queries with n equals 0, 1, and 2. So this is going to get called 3 times as those queries arrive, and it's going to be called in all 3 of the members because he did a multicast query, asked for all replies, right? So all 3 members will print query for arg equals 0. Later they're going to each print query for arg equals 1, and then they're going to print query for arg equals 2. They're going to print it on the console, and they're not going to log it into the file because they didn't use isosystem.writeLine. They used console.writeLine. They create this new list of answers. For each tuple in the database, they walk through. Each one looks at different rows. Then it prints looking at, and it prints the rank slash the value, so whatever the value was in that tuple. And if the rank is equal to the given argument, it includes it into the list and prints that it's doing that, and then eventually it sends back it's part of the list. Okay? And so this is the core piece of code that determines what's going to be in that list. Okay, and now we can ask ourselves, for example, how many items have rank 0? Well, the answer is 5 do, because each one, A, B, and C, put 5 tuples in. Which member will see those tuples? I hope you've realized by now, that's hard to predict. It really isn't predictable. Ordered send told us that each one would see the same database in same order on the items, but didn't tell us what order that would be. All it did was to preserve FIFO-ness and then put the items in order. So we can't know. We just can't know. So until we run the system, the order isn't fully determined. The order that's actually in the database determines who replies with which elements. And so we might actually see a situation in which different elements see different lists. So for perhaps A finds 0, 1, and 0, 3, B finds none, and C finds 0, 0, 0, 2, and 0, 4. Each sends its own list. For example, A sends 1, 3, because those are the values associated with 0, 1, and 0, 3. And if we were to print out the result lists in a fancier way, now the result list right now just prints value, value, value with spaces between them, and furthermore, it prints them in any old order. It doesn't know which member sent a given element to the results list. It just prints them in any old order. We could have sent that information and put them in order, but we didn't do it. So we just get back something like this. We might print 1, 3, nothing, 0, 2, 4. You see? Right? And the output then here would be 1, 3, 0, 2, 4. Here I put curly braces. As a change to the program, you might modify it to really do this. So it's consistent. But what does consistency mean? Consistency here means that every tuple is scanned by one group member, that the set of replies, if it contains 3 replies, indeed contains a reply based on every tuple. There's a 0, 1, 2, 3, 4 value for each possible rank, and the ranks are 0, 1, and 2. And so a consistent answer always shows us the numbers 0 through 4, but not necessarily in any particular order. You see? Oh, here's a homework question, but I've already answered it. What can we say about the ordering within each list event reply element? I'll pause for a second while you think about the answer to that question. All right, well, the answer to that question is each one of the sublists is in increasing order, but on the other hand, that order might not be 0, 1, 2, for example, or 1, 2, 3, because of this issue that different members happen to look at different rows, and we can't predict who's going to look at the rows that were introduced by a given member with a given rank. So, we see 1, 2. That had to be increasing, but you can see it's missing 0 and it's missing 3. There they are down here. 0 and 3 and 4 are down at the bottom. This guy saw nothing. So there's always going to be monotonically increasing, but we can't predict who will look at which row. So you can modify this program, and I want to suggest that you do that. I'd like you to modify the program, first of all, so that if the group happened to have a different number of members, not 3, it could still subdivide the work. And so right now we're subdividing by 3. It's a trivial change, just a line or two. Change it so it subdivides it into n parts. And so if there were 10 members in the group, 10 answers. If there were 2 members in the group, you get 2 replies. All right. Secondly, what if a failure disrupts sending of the replies? Well, you'll be missing a reply. Modify the program to actually be able to detect and print this. If it's missing a reply, have it print out that it's missing a reply. And as a hint, you're going to need to pass back more information, not just the list. You're going to have to start passing back more, like, for example, how many members were in the group when the query was executed, and which member rank is replying. And then with that information, you'll be able to do this. How do you pass back multiple values? You can just call g.reply with a list separated by commas, and then you have to have a results list for each type of thing, and you'll get back 3 lists. One of them will be a list of lists of ints, but the other might be a list of ints or list of strings or whatever you choose to send. And then you should test your fault tolerance logic, remembering that if you kill a program, that works, but it takes about 90 seconds. If you use isysystem.shutdown, have a member deliberately exit, that's really fast. So if you're going to test it a bunch of times, I would recommend getting it to be done through shutdown. You could get the same program to run on Linux. Let me tell you quickly how you would do it. You'll have to follow the instructions carefully to pull it off. First of all, you would download and install Mono on your Linux platform unless your sysadmin has already done that. If they haven't, you can download the package by following the instructions on this website for the Mono project. And then you have to compile Mono, which actually involves 3 compilation steps that are each pretty slow. One of them configures Mono for your particular machine. You'll probably download the Ubuntu version of Mono, no matter what version of Linux you're running. It works fine on Red Hat and other things. The compile configuration step figures out which version of Linux it is, and some files are in different places based on that. Once it knows, then there's a true make file, and you run make, and it figures out how to build every piece of Mono. That takes about 25 minutes. And when it's all done with that, you have to run make install, and it installs the binaries and the libraries in some standard places. But if you're not installing it as super user, you're going to have to put it in your own folder. So then what you're going to do is you're going to create the program that we're talking about, or copy it over and maybe modify it. You can use the Mono interactive development tool if you want. That works a lot like Visual Studio. It actually looks very similar. But you can use any editor you like. You could use visual editing if you want. Then compile it. You're going to say something like mono C#, MCS is the compiler. Put the output into myprog.exe, and you're going to give myprog.cs and isis.cs. The only thing being, I guess you need a capital P for myprog, because apparently I've got that wrong. And also, you may have to tell it where to look for the libraries. If you did install Mono in your own folder, then you're going to have to point MCS to the folder using the -L command. And then it's going to snow in Ithaca, big surprise in the winter. Okay, and then you execute this by executing Mono and Mono on the executable. And Mono is a just-in-time compiler, so what it'll do is do last-second compilation to instructions, and then it'll execute the machine code safely. Some types of Mono installs are going to have a little bit of trouble. One of them is really stupid. I don't know why they haven't fixed this, but for a full year, the Mono make file has had an error in it, which is an underscore that should be a dot, or maybe it's the other way around, a dot that should be an underscore, and the make file crashes. You have to fix that. Just track it down and edit that line. You're also going to have to specify the library path if you install Mono in your own folder instead of in the system folder. And you may have to tell your bash shell where to look for the executables by setting the bash path using an export command and pointing it to the right place, and similarly for the libraries. And the last thing is to obtain useful stack traces. You should know that if you don't tell Mono to compile with debug information by setting a -debug flag at the time you run MCS in Mono, then the stack traces won't have any information in them at all, and you'll know that a crash occurred, but you won't know where it happened. So for development purposes on Mono, definitely set that flag. So to summarize, we created a group. We saw how to launch ISIS. The members joined it, state was transferred to them, they have the identical state, they apply the updates in the identical order. Here goes the state transfer in my little animation, and once the state transfer is done, these updates are also in the identical order. The order is partly predictable because of FIFO-ness, but the order isn't fully predictable because different members might send these FIFO multicasts in an arbitrary interleaving of order. And ISIS itself figures out what order to deliver them in so that everyone sees a consistent state. So here's the last bit of homework. Take the program and modify it to store phone book data. And then modify the query to look up all the phone book entries that have some name. Let's say that they have Harry anywhere in the name. So here's a phone book, and you can see in red are all the names that have a Harry in them. Sam Harriman, Harry Cheney, and Harry Harrison. Okay? Build that and try to get your application to work for phone book data, and you'll probably have to think of how to represent a phone number. A string might work, or 3 integers, or you could have some kind of a special phone book entry object, whatever you like, and get that to run as a way to take something that's simple that you can download. It's the program on my website that you can click to, and modify. Okay, and so let's run the program one more time, and then that'll be it for this demo. So I'm going to shut down PowerPoint. I'm going to switch to the primary screen here. I'm going to rerun Visual Studio. And as you remember, actually I don't even really need to rerun Visual Studio. What I should do is just go back to this debug window here. Remember that this is the folder Visual Studio compiled and put the program in, and this executable is the executable we generated. So let's just run it 3 times. 1, 2, 3. And we'll put those screens next to each other. And now you're going to see that the program is doing just what we've been talking about. Okay, so here's that startup consensus. It turns out the guy on the far right is process A, who's going to start the system this time. There he did it. He started it and he initialized the first view. B and C are initializing and connecting in. B managed to connect in, then C did. A bunch of tuples were added. Oh, just like I predicted, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. So the ones from 0 managed to get through first. And just like we expected, after that, there's a little bit of mixing between the 1s and the 0s. But if you look, no, in fact, they're not even mixing. 0, 1, 0, 1, 1, 1. No, the 1, no, they didn't mix. As it turned out, in this particular run, it got A's, then B's, then C's. But you could perfectly well have seen a mix, right? A blend of ordering, but not FIFO violations. Then we start to see the query that was occurring. So this is member 1. Who's member 1 here? It's this guy. So member 1 is querying the database, and he queries for different values of the arguments. Okay, now there's a bug in the code I gave you, and I want you to find it. Here's the bug. It's printing out 3, not 5 values. Remember we were expecting to see values 1, 2, 3, right? And we, 0, 1, 2, 3, 4. And here we're seeing 0, 1, 2, and I'll tell you what the bug is, but I want you to fix it. If you go back to my definition of the tuples, you're going to see that I've got the rank and the value swapped relative to what the constructor brought in. Change the program to swap them back to where they should be, so that the constructor matches the calls to the constructor and the rank really becomes the rank. What went wrong here is that the rank became the value and the value became the rank. And then rerun this program and confirm for yourself that now it will print 5 values in the right order. And when you've done that, you'll have begun to get used to the idea of working with ISIS, editing programs, modifying them in various ways, debugging them, seeing what happens as they run, and basically you're starting to be proficient. Let's do one last thing. Let's run this program one last time, but put a breakpoint in, because I just want to show you the point I was making before about how confusing the code can look. So I'm going to kill these things off, run Visual Studio for console application 8.solution. Here it is. Launch a copy. Let's have him be the first member. He'll be member A, and I'm just going to wait till he's running. That guarantees that he's member A. Then I'm going to run 2 copies over here for members B and C. We're going to wait until it finishes starting up. Oh, but I better put my breakpoint before that. So we're going to go into my program here, and let's pick a good place to do the breakpoint. How about in this place where it does the queries? So we'll put a breakpoint right there on that right line. Okay? Now that's going to affect this copy, but not the other copies, because those aren't attached to the debugger. The debugger does have an attach command where you can attach more than one program to the debugger. You can actually do that at runtime, but we're not going to do that today. So we'll run 2 more copies, 1, 2. And this first copy throws a breakpoint exception. Okay? Now I can actually shut these 2 others down, and I'm going to do that because they're going to get confused. While we're debugging A, he stopped. And because he stopped, after 90 seconds, B and C were going to get a new view with A dropped. And I just didn't want to deal with that. A is frozen now. So let's take a look at the stack. Do you remember how I was explaining about how because this is an anonymous method, it's called on one of my threads, an ISIS thread, and it's got a confusing method name? Here it is. The thread that called this, we're going to have to hunt him down. He's one of these threads over here, and it's got a kind of an arrow in the left column that tells us that's the thread we're looking for. There it is. It's the worker thread called the foo. This one is calling the groups foo. Incoming multicast delivery thread. You remember how I told you that multicasts, queries start with a multicast, and views are delivered on one thread? Here's the other thread, the P2P delivery thread. The main thread was way up here at the top, you see? So the main thread is sitting on, well actually the main thread at this point is sitting in isis.waitForever. It's highlighted because it's active. And the breakpoint occurred in this other thread, sorry, there it is, way at the bottom, this one. And you can see what's happened here is that thread called all this mysterious ISIS stuff. ISIS set up the thread, and then it waited, and it decided to do a delivery, and it called CB up action, do up call. And then finally here we are calling main anonymous method underscore underscore 2 with an argument. And yet it's in code you wrote, or at least that I wrote, right? And that is my point, that debugging an ISIS application is perfectly possible. I can point to the arg and see that it has value 0. I can look at the database and it has 15 elements in it, and I can look at what the tuples are and what their ranks and values are. So I can debug this program like a normal program if I want to use the debugger that way. But do be aware that the methods being called are being called by ISIS in places that might surprise you. Okay, and it might look confusing to look at. And it gets worse in Mono. In Mono, if you forget to set the dash dash debug thing, then you won't even get any of the naming at all. It'll all be shown as question mark. So you'll have stacks with 7 question marks on it, leading to a line of your code. Okay, so it's definitely debuggable. And the other point I was making is that I've been talking for easily 90 seconds. By now, members B and C would have given up on A and considered that he crashed because he's stopped in this. Now I can single step this guy, no problem, but he's actually been dropped. And in fact, fairly soon, if I start single stepping him, the ISIS timers under the surface will go off, and all sorts of other ISIS stuff will happen, and this program will reconfigure the group. So although you can single step a program, you've got to realize that you're dealing with a piece of a distributed system. And it's not really a self-standing, independent program in the way that normal programs are when you run them on a single machine. So that's something that's workable, but this is why we so often switch over to using these log files so we can kill this guy off. The log files contain a bit of information, and we can put all sorts of stuff in it. So you see, the log files have all sorts of stuff printed, you know? And you know, I'm feeling sorry for you. I think I'm going to fix that bug after all and just show you what happens if we do. So this code, we're back in the solution again. Let's take out our breakpoint. This code defined the tuples, and it had the constructor set the rank and then the value. But if you look at the way the tuples are put in here in the updates, it's actually putting the value and then the rank. So I guess we can fix it here. We'll just change this to say rank, comma, in. Okay? And now we can compile it again. Let's run it one more time. Oops, we're down in the logs folder. 3 copies. 1, 2, 3. Put them side by side. Remember what we're expecting now. We're going to see 5 values, and they're going to be in order. But because each separate reply contained different things, that may have scrambled the order up. Here's our rank 0 member in the middle. And I'm not sure which one is the rank 1 and which is rank 2. I guess the one on the right is rank 1 and the one on the left is rank 2. Okay, and we're waiting for the one on the left to join in. It takes a little while sometimes, but he'll join eventually. Then he sends his updates. And now look at the answers we got from our rank 1 member. It has 5 values, and it's in subgroups that are in order. You can actually tell who sent which answer. You can't tell who sent which answer, but you can actually see the subgroups. Here's 03 was sent by one of them, 14 was sent by another, and 2 by the last. And actually, you can actually figure out who's who. For example, look at this here. Query for arg equals 2, including 2, 2. So we can actually tell that the rank 0 member sent the last of these answers. This guy's including 2, 0, and 2, 3. So 0 and 3 came from the rank 1 member. And including, let's see, here we are, including 2, 1 and 2, 4. So we look at the 1 and the 4, and sure enough, 1, 4. And they came back in an arbitrary order, so the 0, 3, 1, 4, and the 2, those are the sub-answers. And it just happens that the first answer that we got was the reply from the guy who actually has rank 2. The second answer we got is the guy who has rank 0. And the third answer we got is the guy who has rank 2. So go figure, but that's how we got him. All right? And you can actually understand every single thing we're looking at here. You see? So good luck with ISIS, and hopefully you can start by playing with this demo and work your way out from there. And let's kill them off. And that's the end of the